Okay, let's continue working with the Ville-Marie listings data and now conduct some hypothesis tests. For question 1 in the hypothesis test quiz, the null and the alternative hypothesis were given here. The level of significance was given as 0.01, so I'm going to go ahead and plug that in here. Now, I've included the summary statistics that we ran when we were working with the confidence interval estimates, and so I've placed that here for quick reference. So the first step is we want to calculate the degrees of freedom again. So the degrees of freedom is simply just going to be the sample size minus 1, and we get 55.28. So now we need to determine what type of test are we performing. Is it a lower tail test, an upper tail test, or a two-tailed test? And so what you're going to want to do is you're going to want to look at the sign for the alternative hypothesis. So this is the population mean is less than $150, and the sign points to the left. So we know this is going to be a lower tail test, and so that is going to be your first answer. This is a lower tail test. So next, we need to calculate the t-test statistic. But before we do that, we're going to determine what is our hypothesized population mean. So we have our hypothesis statements here, and so our hypothesized population mean is going to be 150, so I'm going to plug that in here. In order to calculate the t-critical value, I'm going to use the Chapter 9 Excel resources. So here is the Chapter 9 Excel resources, and in the problem it was stated that the population standard deviation is unknown, and we have that this is a lower tail test. So we're going to use this formula here for the lower tail test. So I'm going to go ahead and plug in t.inv, and then we're going to input 0.01 for the level of significance and alpha, and 55.28 for the degrees of freedom, and we get a negative 2.33. So here's the formula for the t-test statistic. So we're going to calculate the sampling error first, which is going to be the sample mean minus the population mean. So we have the sample mean of 142.05, and I'm going to subtract 150, and we're going to get a sampling error of negative 7.95. So now all we need to do is divide that by the standard error. Here's the formula. So we're just going to do the sampling error divided by the standard error. So you notice I'm using the standard error that was given to us with the summary statistics. And so that's why even when you're running your hypothesis test for a mean, I would recommend that you also run the descriptive statistics for these questions as well. And so the t-test statistic is negative 2.80. So that's going to be our second answer here. So now we have everything we need to make our decision. So since the t-test statistic is less than the t-critical value, so negative 2.80 is less than negative 2.33, we are going to reject the null hypothesis and conclude that the average price per night in Ville-Marie is below our customer's budget. So this is where it's important that these questions are actually written from a business sense. So instead of saying that we reject the null hypothesis and conclude that the average price per night is less than 150, we're saying that it is below our customer's budget because that is a part of our research for this project. We have identified that this is the price that our customers are willing to pay, and we are running the hypothesis test to determine if this neighborhood is generally priced under our customer's budget. So you want to watch out for the wording when you're answering these questions. All right, let's wrap up this video and conduct a hypothesis test for a proportion. So I'm going to go ahead and click on the Q2-accommodates count pivot sheet. And so now in this question, the null and alternative hypothesis were given here. And we're going to be using the p-value approach for this problem, but I'm going to go ahead and calculate the z-critical value as well. So the level of significance was given to us at 0.01, so I plugged that into here. Next, we want to identify what type of test are we working with here. So we can see that in our alternative hypothesis, we have the population proportion is greater than 0.50. The sign is pointing to the right, so we know that this is going to be an upper tailed test. Next, we want to identify what the sample size is. So this is going to be similar to the confidence interval for a proportion. We could see in the pivot table that the sample size is 55.29. So I'm going to go ahead and just plug in that number here. We also want to identify what is our X, or attribute of interest. This question just continues on with the confidence interval quiz, and we're looking for 3 or more people for the accommodations. And so I'm going to show you that how I did that in that quiz was we just identified by highlighting from 3 to 18. And we could see down here on the bottom, it says sum is 3241. So I'm going to go ahead and just plug in 3241 for X. We're going to calculate our sample proportion again, which is just simply the X divided by N, or 3241 divided by 5529. So then finally, we need to identify what is our population proportion, or P. This is going to be the hypothesized population proportion, and that is going to be 0.50. In order to calculate our z-test statistic, we have our formula here. So I'm going to go ahead and do the numerator first. And so we have the sample proportion minus the population proportion. So that's just going to be 0.5862 minus 0.5. And we get 0.0862. So to calculate the z-test statistic, we're going to go ahead and take our sampling error in the numerator and then divide it by the square root of the population proportion times 1 minus the population proportion divided by the sample size, and we get 12.82. So if we were using the critical value approach, we would need to calculate the z critical value. So I'm going to go to the chapter 9 resources now. So working with proportions, we know we're going to be finding the critical z value, and we know that this is an upper tail test. So we're going to be using this formula here. So we're going to do norm.s.inv and then 1 minus the alpha, and we get a z critical value of 2.33. Now we know if the z-test statistic is greater than the z critical value, we're going to reject the null hypothesis. But let's go ahead and see what the p-value approach tells us. So for the p-value approach, we're going to go back to the chapter 9 resources to find the function to use for there. So for proportions, we're going to be using the norm.s.dist function. This is an upper tail test, so we're going to be using this formula here. And so I'm going to input 1 minus norm.s.dist, and then we're going to input the z-test statistic, and then true for cumulative, and we get a p-value of essentially 0. So since the p-value is less than the alpha of 0.01, we're going to reject the null hypothesis and can conclude that the proportion of Airbnb listings in Ville Marie that accommodates 3 or more is greater than 50%.